Hello everyone. So let's start solving today's Leetcode daily challenge question. So the question is magic squares in a grid. So 3 by 3 magic square is a grid filled with distinct numbers from 1 to 9 such that each row, each column and both diagonals all have same sum. Okay. So we are given our grid of integers and we have to return how many 3 by 3 grids or magic squares are present. Okay, so here while a magic square can only contain numbers from 1 to 9, grid may contain numbers up to 15. Okay, so we have to check 3 by 3 square. Okay, where we need all row sum, column sum, and its diagonal sum should be equal. So if you see this example, so first 3 by 3 this square if you see, then first row sum is 4 plus 3 plus 8 is 15. Second row, 9 plus 1 is 10, 10 plus 5 is 15. Third row, 7 plus 6 is 13 and 2 is 15. So all in this square, we have all three rows have same sum. Now check with the columns. So 4 plus 9 plus 2 is 15. 3 plus 5 plus 7 is 15. 8 plus 1 plus 6 also 15. Okay, all columns also have the same sum. Now check with the diagonal ones. So diagonals is 4 plus 5 is 9, 9 plus 6 is 15, and 8 plus 5 is 13, 13 plus 2 is also 15. So in this way, all sum are 15. So all are same. So that is why we can say this is a magic square. Okay, so if we see second square 3 by 3, so if we see the sum of its diagonal only, so directly we can see it is 3 plus 1 plus 3 is 6. And if we see other row sum or the any column sum, which is greater. So we cannot say that it is a magic square because the sum is not same. Okay, so here it is returning only 1 because here only one square or magic square exists which has same sum of all column, rows and diagonals. Okay, and also it contains all the distinct elements in an square. So why distinct elements? Because here it is said in matrix magic square. Okay, there should be elements from 1 to 9. So only in 3 by 3 matrix we have only 9 elements, so it should be 1 to 9 only, no repeated element or no element which is greater than 9 or less than 1. Okay, so if we see this example, grid is 8. So here 3 by 3 matrix doesn't exist, so directly returning 0. Okay. So first thing what we have to do is first we have to consider any matrix 3 by 3. Okay. And then we will check if all the elements are distinct elements are in the range from 1 to 9. Then if it exists, then we will check with the sum. First we will find the first sum. Okay, so 4 plus 3 plus 8 is 15. Then we will check with the all other column, row and diagonal sums. And if any of the sum is not equal to the sum which we calculated earlier, then we can directly return false. Or we will write different method to check if the magic square is not. So we'll return a false. Then if the sum all sum are same, at the end we'll return true, so we'll increment our count. So we need one count. It's the answer. Initially it will be 0. We need our rows, number of rows are grid dot length, and columns are grid of 0 dot length. Okay, now now what we want to check with each matrix 3 by 3. So if you see this one. Okay, so we have only two 3 by 3 matrix. So till when we have to traverse? So only here we have traversed till 4 and 3. So from 4, so we have 4 3 8 as in a one matrix. From 3 we have 3 8 4 in one matrix. Can we start from 8? No. Can we start from 4? No. So from um, we have to exclude these elements because we want just a starting cell index. So we will traverse it till third element, so including this. Okay, so we will traverse till rows minus 3. including. Okay, so let's say our size is what, 4. Okay, rows is 4 in this case. So 4 minus 3 is 1. So till one index we are traversing. So 4 and 3. Okay, so we are going to pass this I and j. So if I pass this one in the method which we will write to check if it is magic square or not, there will be checking with other three elements. Okay, so I plus plus. Similarly, for column j is equal to 0, j is less than columns minus 3, j plus plus. And here if is magic, then we are passing our grid and I and j. And here if it is true, then we will increment our answer. Okay, now we will return here answer. Now we have to write this method, that is magic. So public boolean is magic. Then here what we are passing, here we are passing grid. And now we are passing the indexes, that is row start comma int column start. Okay, here. Now first what we have to check here is we have to check if this matrix contains the distinct elements with the range 1 to 9. Okay, so we need one array, boolean array, which in which we can say this 1 to 9 elements are seen or not, or visited or not, basically. Okay, so int visited array is equal to new int 10 size. Then here for int I is equal to 0, I is less than what, row start. Wait, I is equal to row start and I less than row start plus 3, I plus plus. So it will be row start, then row start plus 1, row start plus 2. Only three elements we will be checking. Okay, I mean 3 by 3 matrix. So for int j is equal to column start, j is less than column start plus 3 and j plus plus. Now we will check what, if our grid of I j is, okay, is less than 1, or if it is I j, or we can take this in one variable. So let's say int num1 equal to this, and then here num1 is less than 1, or num1 is greater than 9, or, okay, so we want distinct elements, right? So we will check if it is visited of num1. If it is visited, then also we will return what, false, because this matrix has no distinct elements, or it is either out of range. Okay, or else what, here we have to make visited of this num1 is equal to true. Okay, so now if we get out of this loop after checking all the condition, that means we have all elements in our matrix are distinct and in the range. Now let's check with the sum. First we will calculate the sum as our first row. Let's say first row, you can calculate first column as well, no issue. Then grid of grid of first is row start, okay, and column start. So this will be our first element. So let's say we have passed 0 0, so row start and column start. If you want to go in this direction, then we have to keep the row start as the same, and we need to increment the column start. So here grid of row start column start plus 1. Okay, and next grid of row start column start plus 2. Okay, so we have calculated sum. Now what we want to do is we want to calculate the sum for all rows, all columns, and all diagonals. So for columns and row, we will using a loop for int I is equal to row start I less than row start plus 3, then I plus plus. Okay, now here our what we want to check, if okay, if let's take this same thing because we have to check with the sum, right? Yeah. Now if so for each row, this element, that is this I and column start, then for this element it will be column start plus 1, so it will be I. Okay, this will be I. So basically we are checking for all, and we are checking in this way for each column values. Okay, so grid of I and column start, I and column start plus 1, I and column start plus 2. So if it is not equal to sum, okay, if it is not equal to sum, then we will return false because we want the same sum, right? So similarly this is for column, we want to do this for row. Okay, for row, so we did this for row and we want to do this for column, right? So here I'll write column start, then okay, then here as we are traversing this, I will come here, hi I, but not plus 1, I plus. Okay, now here instead of I row start. So what we are checking, we are checking for each column. Okay, so here for row start, okay, for row start, okay, we are checking in this way, in this way. So our I loop is for this, in this direction, that column start plus 1, column start for 2, and whatever in if condition we are checking, we have to check in this direction, that is we want to increment our rows. Okay, so here row start, and here it should be row start plus 1, it should be row start plus 2. Okay, and if it is not sum equal to not sum, it is not equal to sum, that is means we have to return false. Now check with the diagonals, we have to check these two diagonals, we can directly check with the condition if, what are our diagonals, grid row start, column start, okay, plus grid row start plus 1, column start plus 1, this for this element, it will be row start plus 1, and column start plus 1 plus grade of, what is this, this is row start plus 2, column start plus 2, row start plus 2 and column start plus 2. Okay, we if it is not equal to sum, then we will return what, will return false. Similarly for next diagonal is this one, so here it will be what, if it copy paste, and here we have to check this. Now this is what, row start is same but column is incremented twice, so row start plus column start plus 2, so this element, now row start plus 1, column start plus 1. Okay, here our column start, it's same, this is the first column only, but row is second, I mean second index row, so we have to add 2 in row but not in column, and if it is not equal to sum, we will return false. Now at the end we will return to if all the condition gets satisfied. Okay, so let's check bad operand or, okay, so here we have to make only one or yeah, it is a binary, right? It will be boolean. So if num1 is less than, or num1 is greater than 9, or our visited, mhm. Yeah, okay, wait. Here we have made int, right? It is boolean. It should be boolean, right? So here it is giving either true or false, or we have to make. Yeah, you can see now our sample test cases are passed. Let's submit the code. Okay, it is giving output as a 0. Expected is 1. So is anything which we made mistake here? So here 8 plus 1 plus 6 is, yeah, okay, wait. Here we have made one mistake. Let's run. So here we have to include, right? And still here, not till here. It maybe it is going till here, so it is not doing it. Yeah, now we can say accepted. So here only we have to use or less than or equal to. Here we have used, but by mistakenly I didn't use it. So in this way we can solve this question. So thank you so much for watching this video. And if you feel this video is helpful to you, then please like this video and subscribe my channel. Stay updated.